Happy morning to all. Happy morning. Okay. In the last video, some of the students asked some questions regarding for how to balance the equation. That's the third lesson. P block 11. It's question number 29. And also the page number is 99. Okay. Today I will explain how we are going to balance the equation. Okay. Okay. Anyhow, today learning objectives to learn about the variation of atomic size of 3D elements. The variation of atomic size of 3D elements. Today our learning objectives. All of you know that in the periodic classification, while from left to right, I am saying about the left to right, while increase the atomic number, decrease its atomic size. Okay? Left to right, increase the atomic number, decrease the atomic size. Okay, here, what's the reason is, the proton increase the nuclear charge by 1 unit. Okay? Proton increase the nuclear charge by 1 unit. Electrons are adding in the same subshell. The electrons are adding in the same subshell. That is, suppose the 3D means scandium. What is the atomic number of scandium? It's argon 3D1 4s2. Okay. Next about titanium. Argon 3D2 4s2. Like that 3D subshell. Here the electrons are adding in the 3D series. Am I right? So atomic number increasing, atomic size is decreasing. Here proton increase the nuclear charge by 1 unit. By one unit. So electrons added to the same subshell. So atomic size is what happening? Atomic size is decreasing. This is about the left to right. What is about the top to bottom? Top to bottom. From the top to bottom. Here also the atomic number is increasing. Here atomic size is also increasing. Here the added electrons are not in the same subshell. It on the different subshell. So another next subshell. As the subshells are increasing, the atomic size is also increasing. From left to right, the atomic size is decreasing. From top to bottom, the atomic size is increasing. This is the concept. In the 3D series, we have 10 elements. How much elements? 10 elements. From scandium to zinc. The scandium, the atomic number is 21. And titanium, the atomic number is 22. Vanadium, the atomic number is 23. Chromium, atomic number is 24. Manganese, atomic number 25. And iron, atomic number 26. Cobalt, atomic number 27. Nickel, atomic number 28. And copper, atomic number 29. And also zinc, atomic number 30. These are the atomic numbers. Then the electronic configuration regarding for this 3D series. Scandium, argon, 3D1 4s2. About the titanium, argon, 3D2 4s2. Next about the vanadium, 3D3 4s2. Next about the chromium, 3D5 4s1. Manganese, 3D5 4s2. About iron, argon, 3D6 4s2. Next about the cobalt, 3D7 4s2. Nickel, 3D8 4s2. And about the copper, argon, 3D10 4s1. About the zinc, argon, 3D10 4s2. These are about the atomic numbers and as electronic configuration. Here, what is happening in the 3D series? Why the size is increasing? Why the size is decreasing? Why the size is almost constant? Here having scandium to vanadium. Scandium to vanadium, the atomic size is decreases. Okay. from scandium to vanadium, the atomic number 21 to vanadium, the atomic number 23, the size is decreases. And also from chromium to copper, the chromium atomic number is 24 and to copper is atomic number 29, the size is almost constant, almost constant. And about the zinc atomic number 30, the size is slightly increases. The atomic size is slightly increases. Why? What is happened here? What is the reason? There are some following reason. From scandium to vanadium, scandium to manganese, the effective nuclear charge is greater than the shielding effect. Okay? From scandium 3D series, scandium, that is atomic number 21 to manganese atomic number 25. Here the effective nuclear charge is greater than shielding effect. What is about the shielding effect? What is about the effective nuclear charge and shielding effect? The effective nuclear charge is the net positive charge experienced by an electron in a polyelectronic atom. Okay. Effective nuclear charge is the net positive charge experienced by an electron in a polyelectronic atom. What is about the shielding and what is about the screening effect? The shielding or screening effect. It can be defined as the reduction. It can be defined as the reduction of an effective nuclear charge by an electron cloud due to the difference by the attractive force in the electron in an atom. Okay, it is defined as, what is about the defined as the reduction of what? Reduction of effective nuclear charge and the electron cloud due to the difference in the attractive force on the electron in an atom. Okay, here across the period, what happens to the effective nuclear charge? Across the period, the effective nuclear charge increases and electron shielding effect remains constant. Okay, clear? Across the period, and I say about the left to right, across the period, the effective nuclear charge increases and electron shielding remains constant. Increases in electron, the shielding remains constant. Why the atomic size decreases? What's the reason? Have some reason. Here, the shielding effect and also the effective nuclear charge. From scandium, the atomic number 21 to manganese, atomic number 25, the effective nuclear charge is greater than the shielding effect. The effective nuclear charge, we can say that on Z star, the effective nuclear charge is greater than the shielding effect. From scandium to manganese, the effective nuclear charge is greater than the shielding effect. What about from iron to nickel? From iron to nickel, that is atomic number 26 to atomic number 28, the effective nuclear charge is equal to shielding effect. Okay? What's the first condition? From scandium 21, atomic number 21 to manganese, atomic number 25, the effective nuclear charge is greater than shielding effect. The second one is from iron, that is atomic number 26 to nickel, atomic number 28. The effective nuclear charge is equal to the shielding effect. The last one from copper to zinc, the effective nuclear charge is less than shielding effect. This is one of the conditions. Here, as we move from scandium to zinc, here in the 3D series, I told you about the 10 element. The 3D series, when an extra electron is added to the 3D orbital in 3D series, an extra electron is added in the 3D orbitals and increase the nuclear charge. And the nuclear charge is increasing. So what happened? Hence the effective nuclear charge Z star is increased. This is one condition. Let us write how the nuclear charge, what happened, the 3D shell and what happened the force. Okay, please all of you take the note and we can write one or two electronic configuration. We can write the electronic configuration for scandium. Yes. What's the atomic number? 21. Argon 3D1 force 2. Okay, this is the electronic configuration. This is and the nucleus. I think that is the last station. You can take as the last station. Okay. For example, D subshell. D subshell, how much electron is there? Only one electron. Okay. What about the fourth subshell? The last two electrons. Okay. Here, for the nuclear attraction, it will be the D subshell and 4 electrons. Okay. D subshell, between the D subshell and 4 having formed what? There is a shielding effect, one of the shielding effect. This screening the nuclear attraction. Okay? About the argon. What's about the titanium? Titanium is equal to 22. Argon 3D2 force 2. So this is outer, okay? And the D subshell. How much electron is here? 2. What about the 4? Here also take next 2. Here also shielding effect. What is the case of manganese? In the case of manganese, atomic number atomic number 25. Argon 3D5 force 2. Okay? D subshell. How much electron is there? 5 electrons. 1, 2, 3, 4, 5. What about the 4s? How much electron? 1, 2. So here, what's the condition? The effective nuclear charge is greater than effective nuclear charge is greater than shielding effect. Okay? The effective nuclear charge is greater than shielding effect. Clear? Because the outermost has only how much electrons? 2 electrons. Here the innermost, how much electrons have? 1, 2, 3, 4, 5. These subshell having 5 electrons. Okay, clear? And also the size is, what happens? Size is decreases. Next what about the size between chromium 2 copper. Chromium to copper. The atomic number of chromium 24. Atomic number of copper 29. Okay. Here we can discuss. Okay. The first one chromium. I told you about the electronic configuration, that is argon 3D 5 force 1. Here copper argon 3D 10 force 1. Okay. Here about the argon, I am drawing the 3D. How much electron? 5. 1, 2, 3, 4, 5. This is the 3D. Force forest. Only one line. What about copper? One, two, three, 4, 5, 6, 7, 8, 9, 10. And forest. This is the 3D. This is the forest. Here two forces are forming. The two ripple. For example, this is the 3D orbital. This is the forest orbital. Okay, forest orbital electrons. Here two forces are operated in the opposite direction. Here two forces are operating. Two forces are operating. In between 3D subshell and the forest subshell. Okay, in opposite direction. They tend to balance to each other. Okay, there's attraction between, we can say the attraction between the nucleus and the last forest electron. Okay, and also the electrons, attraction between the electrons and also proton, maybe taken as like that. Here, the two forces are operating in between the 3D and the forest. Here, they tend to balance to each other. These two forces are operating, they tend to balance to each other. So, here from chromium to copper, the atomic size become constant. What's the reason? The two forces are operating in opposite direction and then they tend to balance to each other. So, chromium to copper, the atomic size become constant. What is about the zinc, isn't it? What's the atomic number of zinc? The atomic number of zinc is 30. Okay? Atomic number of zinc is what? 30. What is the electronic configuration? AR 3D10 4s2. AR 3D10 4s2. Here zinc contains 10 electrons. How much electron in this subshell? 10 electrons. Here the repulsive interaction between the 3D subshell and forest. This is the 3D. 3D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What about the forest? This is the forest. Okay, here 3D and the forest having some repulsive interaction. Okay, repulsive. Repulsive interaction between 3D and forest. Electron is more than the nuclear charge. Hence the orbital is slightly expand. In this repulsive interaction, the repulsive interaction is what happened here? More than the effective nuclear charge. Hence the orbital is slightly expands. So the atomic size is increasing. Okay. So what is about the atomic variation of atomic radius in 3D orbital? I already told that. About what is about the condition? What are the conditions? First, the atomic size is decreases. Next, the atomic size become constant. Next, the atomic size become what happens? Increases. That means scandium to vanadium. The atomic number what is around? Sc to vanadium. That is atomic number 21 to 23. Okay, atomic number 21 to 23, the atomic size is become what happen? Decreases. Okay, here. And about the chromium to copper, the atomic number is 24 and the copper is 29. Here, the what happen is here is constant. Constant is not constant, almost constant, okay. And about the copper, from copper, start with copper to zinc. Zinc means its atomic size is increases. Atomic size, okay? Here about the chromium to copper, the force from the 3D orbital repel the force electron. The two forces are operate in the opposite direction. From chromium to copper, the two forces are operated in opposite direction. They tend to balance to each other so that the atomic size become constant. In the case of zinc, don't forget that the case of zinc containing d subshell about 10 electrons. Here having the repulsive interaction between 3D and the first. 3D and the first is more than the effective nuclear charge. Okay, is more than the effective nuclear charge. Hence the orbital is slightly expand. Now the atomic size is increased. This is about the variation of atomic radius of 3D element. Okay. Next about the doubt clearance about the previous video. About the doubt clearance. I think that the page number is 99. Page number 99. Question number. It's a state board. First volume book. First volume. Question number 23. Question number 23. Question number 23. Complete the following reaction. Complete the following reaction. The question. What's the first question? Question number 1. Here, sodium chloride. The sodium chloride reacts with the manganese dioxide MnO2. The presence of sulfuric acid. Okay, sodium chloride reacts with manganese dioxide in the presence of sulfuric acid. The question is the preparation of chlorine. That's the question. Here the chlorine is prepared, am I right? That is, we get Cl2 plus Mn combines with the Cl2. This Mn manganese combines with the Cl2 to form MnCl2. What's the product? Mn combines with the Cl2 form MnCl2, and also sodium combines with the sulfuric acid containing bisulfate ions. Sodium combines with the bisulfate ions to form sodium bisulfate, that is NaHSO4 plus. Here hydrogen having oxygen having to form water. Here you have no doubt about the solving for balance the equation. How much chlorine is there? 2 chlorine, 2 chlorine. How much chlorine is there? 2 plus 2, 4 chlorine. So make it 4 here. Here. So how much sodium is there? 4 sodium. So make it 4 sodium here. Now how much sulfate is there? Sulfate. 4 sulfate. So make it 4 sulfate here. Then about the water. Water, how much? Hydrogen? 4 2s are 8. Already 4 over. Then remaining 2. Down the element is balanced. All are balanced. Have it down. About the first question. Sodium chlorine, manganese dioxide, sulfuric acid. Preparation of chlorine. We get Cl. Manganese chloride, sodium bisulfate and water. How much chlorine? 4 chlorine. Make it 4 here. How much sodium? 4 sodium. Make it 4 sodium here. Sulfate 4. Water. Balance. Now the equation is balanced. What about the next one? Sodium nitrate. Okay, that is NaNO2. This one reacts with hydrochloric acid. So what's the product? Na combines with Cl. So what's the product? NaCl. Okay. Then H combines with NO2 to form HNO2. Have it out? Nitrous acid. Okay, nitrous acid. HNO2 means nitrous acid. Okay. The third one. Phosphorus. Phosphorus reacts with sodium hydroxide in the presence of water. The first product is POSP. What is the formula for POSP? pH. Okay, we get POSP. Next, what is the product? Sodium combines hydrogen with the phosphorus and oxygen to form sodium hypophosphate. What is the formula? Na2. Sorry, it's a sodium phosphate formula. NaH2PO2. Okay, NaH2PO2. How can you balance the equation? Listen to all of you here. Here having 4 phosphorus. Here having 2 phosphorus. Here having 4 phosphorus. Here having 2 phosphorus. So make it here 3. So phosphorus balance. How much sodium is there? 3 sodium. Make it 3 here. Then what about the hydrogen? 3 into 2 is equal to 6. 6 plus 3 is equal to 9. So how can you balance it here? 9 means here 3 over. Then make it 3. So 3 2s are 6. Now the equation is balanced. Clear? Phosphorus 4. Here also phosphorus 4. Phosphorus plus 3. Okay. Have it out. Next one, the fourth one. Silver nitrate. AgNO3 reacts with POSP. What's the product? This Ag combines with P. This Ag combines with P to form silver phosphide. Formula what? Ag3P. Plus hydrogen combines with the nitrate to form HNO3. How much silver is there? 3 silver. So make it 3 here. How much nitrate is there? 3. So make it 3 here. Now the equation is balanced. Have it out. Next about the fifth one. Magnesium. What is the symbol of magnesium? Mg. This magnesium combines with nitric acid. The magnesium combines with the nitrate. What's the product? Magnesium combines with nitrate from magnesium nitrate. Okay, yeah. The formula MgNO3 twice. Okay. Hydrogen plus H2. 2 hydrogen, make it 2 here. Balance. Have it out? No. What about the sixth one? Potassium chloride. Formula what? KClO3. Potassium chloride. Potassium chloride on heating. What is the product surrounding? KCl plus oxygen. KCl plus O2. So what's the product? How can you balance the equation? 3 oxygen, 2 oxygen. Make it 2 here. So oxygen balance. What about potassium? 2. Now the equation is balanced. Okay? Have it down. What about the next seventh one? Seventh one can be reaction between copper plus sulfuric acid. Here we are using concentrated sulfuric acid, not a dilute sulfuric acid. We are reaction between copper and sulfuric acid. So copper sulfate is formed and also sulfur dioxide gas is also formed. Okay. Copper combines sulfate to form CuSO4. plus sulfur dioxide plus water. How much sulfur is there? 2. How much hydrogen is there? Now the equation is balanced. Okay? 2 4s are 8 for oxygen. 4 plus 2 plus 2. Now the equation is balanced. Have a doubt? This is the lower section. Okay, how to balance the equation. Don't worry, if you are taking return practice, you can be easily write the equation. Next about the 8th one. That is Sp, antibody. Antibody reacts with the chlorine. Sp converts the chlorine to form SbCl3. SbCl3. Here 2 chlorine, 3 chlorine. So make it 3 here. We get 6. Am I right? 2 here. 6. 2 Sb, 2 Sb. Clear? Have it now. Next about 9th one. Hydrogen bromide, HBr, hydrogen bromide. This hydrogen bromide reacts with the concentrated sulfuric acid. Okay? Hydrogen bromide reacts with the concentrated sulfuric acid. Here the first one is forming is Br2 and also forming sulfur dioxide gas. Which gas? Sulfur dioxide. Just hydrogen combines oxygen from water. How can we balance the equation? Here we can make it 2 here. And how much sulfur is there? 2 sulfur. Then also we can be, now the hydrogen is not balanced. How can we solve this one? Means make it 4 here. So how much total, how much hydrogen is there? 4 plus 4, 8. So make it 4 here. Now the equation is balanced. Clear? And what about the bromine? Here I have 4 Br, so make it 2 here. Now the equation balanced. Here, have it out. And especially for the 10th, 11th, 12th, 13th, the 4 equations are very important question. Tenth question. That is a xenon hexafluoride, XEF6. Xenon hexafluoride. This xenon hexafluoride on react with water. The hydrogen combines the fluorine to form. Hydrogen combines the fluorine to form hydrogen fluoride. What's the remaining product? Xenon combines the oxygen to form xenon trioxide. How much fluorine is there? 6 fluorine. So make it 6 here. How much hydrogen is there? 6. So make it 3 here. How much oxygen? 3 oxygen. Equation is balanced. Okay? Next about 11. This also when we take that one. XeO6 4 minus. Percentile ion. Okay. This all react manganese ion, Mn2 plus, manganese ion, the presence of H plus ions. So what are the possibility product? Permanganate ion, that is MnO4, MnO4 2 minus, O4 4 minus. Okay, and also we get XeO3, xenon combines oxygen to form XeO3. Here I have hydrogen. So what's the product? Water compulsory. That is water. So Mn2 plus, make it 2 here. 2. Now Mn also solve. Here make it 5. So X is also make it 5. So how much oxygen is there? 5, 6 are 30. Here oxygen is equal to 30. Am I right? What about here? 2 4s are 8. 8 plus 5 into 3 is equal to 15. So how much? 23. What's the remaining oxygen? 30. 23 over 7. Make it 7. So how much hydrogen is there? 7 into 2 is equal to 14. So make it 14 here. Now the equation is balanced. Clear? Then what about the 12th one? What about the 12th one? What about the 12th one? XCOF4 XC. So now an oxy fluoride, okay. React with the silicon. So what's the product? XII reactive. What's the product? Silicon tetrafluoride. And also XC combines with oxygen and oxygen. We get XeO3 plus SiF4. Okay? Can you balance? Okay, what? Is it balanced? XeO3, XeO3, XeO3. Equation is balanced. Next about the third endo. Xenon reacts with the fluorine. Very, very important question. Xenon reacts with the fluorine. And also you should be write the temperature. Nickel 200 atm and 400 degree Celsius. Okay, 400 degree Celsius. What's the product? Xenon hexafluoride XeF6. Fluorine 6, make it 3. Okay. Now the equation is balanced. Am I right? And if you have any doubt, please again call me, I will help you, okay? You should be take return practice again and again. You should be write the equation. Chemistry means fully equation. Try to balance the equation, okay? And again you should be write the equation repeatedly. And today also I am giving the same assignment, the page number 99, the same assignment. I think that we get the 13th question. At least you should be write one time. Okay, all of you write the assignment. This is a very important area. Today assignment. Page 99. This is a compulsory question. Question number 23. Okay. Thank you all for your time. Have a nice day.